On behalf of RBCS and software test professionals, welcome to this webinar on test management and quality management. I am Rex Black. I'm the president of RBCS. We are a worldwide testing and quality assurance firm. We have clients that range from small startups to Fortune 20 global enterprises. We've been in business since 1994, delivering insight and confidence to hundreds of clients around the world. Our team of international consultants deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. I'm the author of 10 books on software testing, including the best-selling Managing the Testing Process and a couple new ebooks, one on testing metrics and another called Improving the Testing Process, Value-Based Approach to Assessing and Enhancing Testing Maturity. You can find those on our store on the RBCS website, rbcs-us.com. RBCS is presenting this webinar in partnership with Software Test Professionals. You can check out their website at www.softwaretestpro.com. Software Test Pro, all one word. Attending today's webinar may earn you credit for QAI and or ASQ recertification, so check with them to determine how you would qualify. Typically, it would involve saving the attendee email that you will receive from us after this webinar. You definitely will get PMI PDUs if you need those for attending today's webinar. Thanks to Rex Price for reviewing the materials for PDU status and for making some valuable suggestions. Visit pmi.org to claim the PDUs using the code TMQM100. RBCS's provider ID is 2986. PDUs are available for live webinar attendance only, so if you're listening to the recorded version of this, do not try to claim those PDUs. You may get audited. We've had people tell us that that's happened to them. Now, before we start the presentation, a couple housekeeping notes. You can submit questions at any time during the webinar, but please note that I will only have a chance to look at them at the end after the main presentation. You do not need to ask for presentation copies. The presentation is on the web. Go to the rbcs-us.com website. You'll see a resource tab in the upper middle of the page. Go to the resources and navigate from that tab to the basic library. You'll find a PDF version of this presentation at the bottom of the basic library. You also do not need to ask about the free e-learning. Simply by attending this webinar, you have been automatically registered for the free e-learning. So watch your email over the next couple days and be sure to check the spam filter. Sometimes those get caught in there. Now, if you are having any problems with the audio or video components of this, getting to the webinar, try contacting GoToWebinar support in long term. Generally, when people have problems, they come down to one of three things, which you might be able to fix. One is browser incompatibility. Not all browsers work with the Citrix GoToWebinar software, so you can try a different browser. Another thing is audio settings. So, if the audio is really muffled or quiet, try to change your audio settings. That can work for people. And then finally, a little harder to solve, company firewalls sometimes block or companies' policies prevent the installation of the Citrix software. And in that case, you would just have to get your company to change their policy or listen on a home computer. There will be a rebroadcast of this or rerunning of this webinar at 8:30 Central Time this evening, so you could try it then. I hope you enjoy these free webinars. They are a service to the software testing community because at RBCS we are a not-just-for-profit company. So on with the show. Today's presentation is about test management, quality management, and the differences and overlaps, relationship between those two things. Some people seem to think that test management and quality management are the same thing. Others have a better understanding that they are actually different. Now, testing relates to quality, obviously, but testing is not the total solution to quality problems. There is a lot of confusion here, and we've run into this with a number of clients being confused about, what's the difference between these two things? What's the relationship between these two things? What can testing do for us in terms of quality? So, purpose of today's webinar is to help clear up some of the confusion and questions, and help you maybe educate some people in your organization about what testing can and can't do, and what reasonable expectations are in terms of quality. So I picked out 5 key lessons in terms of testing and quality. So I'll show here, and then I'll go into more detail in those in this presentation. But just to give you an overview of where we're going, the first one is that testing is a skilled activity. The second one is that testing has a quantifiable defect detection effectiveness. In other words, you can measure how many defects can be found by testing. Third is that the trade-offs that people talk about, we just have to settle for good enough because we don't have enough time. Those schedule, budget, and quality trade-offs actually are something that happen later in the life cycle and can be avoided if the right things are done early in the life cycle. There are bugs in the wild and there are bugs in captivity, and those need to understand the implications of that fact. There's a gap there in many people's minds. And then finally, testing can be integrated into quality management. It can be an important part of quality management, but as I said, is not the only thing that we can do to manage quality. So let's start here with the first important lesson. Testing requires people with particular skills. Now, you know that you're dealing with an organization that has confusion on this point if you hear people make comments like, well, anyone can test. It's not that hard. All we have to do is just make sure that there aren't any bugs in the product before it ships. Well, we'll deal with the aren't any bugs in the product before it ships, or make sure it works before it ships question here in a moment. But this idea that just anyone can sit down and push buttons and voila, that's testing. That's widespread in the industry, but not a good practice by any means. Now, I say it's widespread. I have a term that I use for this. I call this pardon me. Call this amateur testing, which would be testing that's done by someone other than a skilled test professional. And there is a place for amateur testing, which I'll talk about in a moment, but generally what you see when testing is being done by people who are not professional testers is that their effectiveness in terms of defect detection, in terms of risk mitigation, in terms of confidence building, etc., is lower. And it's also generally less efficient. If we measure it in terms of cost per bug found or requirements covered per, really covered per hour, that kind of thing, it's, generally not as efficient either. So this idea that by using cheap, oftentimes, and or unskilled people to do testing, that's going to solve the problem quickly with a minimal cost is actually incorrect. Now, when we say testing requires skills, and that of course brings up the question of, well, what skills? And what we've seen with clients, and what I've noticed in my own personal experience managing test teams, is that you really want to have a proper balance of people who understand the underlying technology behind the application being built, people who understand the problem that the application is supposed to solve, the business expertise, the business understanding to know, what a solution looks like, and then also testing skills. Testing does require certain specific skills related to things like test case design, test automation, and so forth, and those skills need to be grown as well as the technical and the application skills, and that tends to be where a lot of companies really kind of fall down. They often will understand that there's a need to understand the application, or they'll understand that there's a need to understand the technology, But testing itself, the test-specific skills are even in some fairly sophisticated companies not understood properly and not necessarily properly managed. Now, another thing that I'd point out here too is that managing testing is different than managing other things. Now, there are some exceptions to this rule that testing should be managed by experienced test managers. Working with a client right now where the person who's in a director of testing position is brought in from application development side of the house, and he's been quite successful. But as a general rule, there are some very unique and specific things that come up in managing testing that an experienced test manager will be much better equipped to handle. So let me give you a case study here to illustrate my point that testing skills are important. We had a client that was using their former support staff to do their testing, so the technical support people had been pulled in, and they did not have any testing skills or testing experience in general, but most of them prior to being put into that group had never tested an application before. So that had some pretty significant impact on their effectiveness and efficiency. So one of the things that we did for them was run all of their testers through our ISTQB Foundation certification course and the exam. And so that was a fairly significant undertaking. We're talking about well over 100 testers. Now, you might say, well, gee, that's pretty expensive. Training 100 plus testers. I think we had like 6 or 7 classes that we ran. It's a lot of money, and what do they get out of that? Well, basically, one of these guys, after taking the class, he went off and looked at their regression tests. Now, regression testing was a significant share of the work that they did, and what he found was that they had a lot of redundant regression tests based on a technique called equivalence partitioning. He was able to see, hey, we're over testing a lot of these areas that we're testing. These 2 or 3 or 5 test cases don't tell us anything that one of them wouldn't tell us. So they were able to eliminate the redundant tests, which freed up over 25% of this test team's time to go do other things, do things that weren't being tested as well. So you can see there's an immediate and significant payoff for increasing the testing skills in this particular organization. Now, I'm not going to hold this out and say, this is typical, and that everybody that runs through one of our foundation courses is going to, every organization is going to immediately have a 25% increase in their efficiency. But it's not completely unheard of in our experience. We've seen that when you do introduce proper training and proper skills in testing into test teams that do not have them, it is a very significant jump in their ability to work effectively and efficiently as testers. Now, it is very important that the courses that are done or used to do training, that they focus on hands-on skills. I just want to mention that there are some training out there that might be more focused just on vocabulary and those sort of things. And what we're talking about here is an actual hands-on training course that taught people how to create test cases using the various techniques. In that sort of situation, you will tend to see a significant increase in capability. Now, I said a moment ago that there is a place for amateur testing, and I want to kind of illustrate that here. Let me get the spotlight up. Okay. Now, this is one of our clients. The way they promote software from projects into their production environment. This is sometimes called the train model of managing software releases. So the way this works is that they have testing windows, if you will, testing schedules. And you see here we've got, this is a testing period that's scheduled for May release. So this is the May release going into production here. Time is going this way, right? So this is the May release, okay? And 2 months later, we've got the July release. So we've got some parallel testing tracks going on here. And what happens is that about, I think it's about 8 weeks prior to the scheduled release, there's a cutoff period. And any project that's ready for system integration testing can promote or deliver its software into that that candidate bundle. So what you see here is that projects 1, 2, and 3 are ready. In other words, the system testing, as you see here, is complete, and so that code will get incorporated into the May release. Projects 4 and 5 are not ready, so they will have to wait for the July release. So that's what's happening there. Now, let me go through how this work is divided up, testing work is divided up, and indeed the quality work in general, and you'll see how this incorporates the ideal blend of skills. So on each project, at the beginning of the project, there's a specification period. Now, I've not shown this here because it would have made the graphic a little bit more complicated and maybe even being confusing. But in an agile world, you would have, of course, specification happening at the beginning of each sprint, and they do have agile projects. But whether we're talking agile or traditional sequential life cycle, there will be requirements reviews, and if there's a design specification, those will also be reviewed. Those are mandatory activities under their life cycle rules, and those activities are actually led by the independent test team. So they're analysts, they're more senior testers. One of the services that they provide to the organization is organizing and leading the reviews. So that's happening here. And just to back up a little, there is a independent test group that is independent of all the project teams, those are the independent test team that I'm talking about here. These are skilled professional testers. Now, there's development and unit testing that then happens. That unit testing is mandatory. Of course, it is at the discretion of the developers. But they are expected to unit test to some level of sufficiency. I'll talk a little bit more later about limitations on that, but they are expected to do that. There is component integration testing, which happens on some of the projects if the project is big enough that that's something that's needed. That's optional. That's done by the development test team and the programmers. So there are, in each of these projects, there's a separate group of people that are acting as independent testers, and they are trained to some extent as testers. That they're reporting to the project manager, so they're not a true independent test team in that sense of the word. But they do then system testing. System testing is mandatory. That's done by the development test team. And it's the results of the system testing that determine the readiness for inclusion in a release. There's a couple metrics that they look at to try to determine whether they've found and removed enough bugs from the project in order to be able to get into system integration testing. So then, once they get into system integration testing, then that's when this independent test team, which includes both employees and some in-sourced contract testers, takes over. They are augmented by the security team. This is a bank, and so the bank has a separate security team that comes in and does the security testing. And then, then at the end, we have user acceptance testing, which is mandatory. It's done by the users, supported by the independent test team. And these users who are carrying out the user acceptance testing are generally experts in the application that's being tested. So what you can see here is that we have a mix of skills being deployed. We've got people that are very strong in testing in the independent test team. We've got people with strong development experience, very technical people be involved in testing at the unit test and component integration test when that happens. We've got people with very strong application knowledge being involved as well. So I was talking about that mix of skills. Now, to some extent, you want to have that mix of skills in your project, in your test team. But you also want to have that same kind of mix of skills in the project team as a whole and divide up the testing and quality work across that team. So you don't want to have an approach where, like, there's no testing happening until here, this is a common worst practice of people say, oh, I'm not going to worry about testing. I'm just we've got an independent test team and they'll take care of it all at the end. That approach definitely does not work. Okay, now I mentioned this before of this fallacy of make sure it ships before it, or make sure it works before we ship it. Associated with that, I guess, would be hearing a comment like this: "Well, we have bugs in production, and so the testing failed. Why didn't you find that?" Is a question that sometimes testers hear. It's funny. There's some sort of interesting psychology here, because I have never heard a user or a project manager or quality manager or anybody like that go up to a developer after a bug is found in production and say, "Why did you put that bug in there?" But instead, the question is asked to the testers. Why did you let that bug get out? I mean, well, the tester missed the bug for the same reason that the developer put the bug in there, which is to say that human beings are fallible and they make mistakes. In addition, testing is under the constraint that there's an infinite number of tests that we could run and only a finite amount of time in which to run them. So the thing that's important to understand is that within any given process, the broader software development process, and then embedded within that, the testing process, which is a theme I'll come back to later, that testing that's carried out has a quantifiable defect detection effectiveness. In other words, we can measure how effective testing is at finding defects, and it will tend to be pretty stable as long as the process doesn't change. So it is not a matter of, should not be a matter of, individual accountability here. It's a matter of, there is a process. The process has been ideally been defined by management. In some cases, it's not defined. It's just grows out of reacting to events, which is by no means unusual, but certainly unfortunate. And that process has a certain level of quality capability. And part of the software development process's quality capability is the defect detection effectiveness of testing. And now when I say defect detection effectiveness, what I'm talking about here is the percentage of defects that are found in any given testing or quality activity. So if there are 100 defects in a requirement specification, and we have a requirements review, and we find 50 of them, then we have a 50% defect detection effectiveness of that review process. Similarly, if we're going into system tests, say at the end of testing of an application, and there are 1,000 bugs in the product, and we find 850 of them, we have an 85% defect detection effectiveness. Now, simple math, simple example, but a lot of people will look at that equation and go, okay, I understand how to count the number of defects detected, but what about the number of defects present? So in order to get a better grasp on this, let's step back for a second and think about this in the context of the entire software development lifecycle. So this is shown using a sequential model. I can and have drawn similar pictures for what would happen if we were following an agile approach. But what you have is in every activity that creates a work product, whether it's a code that's actually going to be delivered or some sort of precursor work product like a requirement specification or a design specification, defects will be introduced. And so we've got defects that are being introduced. Now hopefully there's some sort of quality assurance or testing activity that's going on for each work product that's removing defects. So some number of defects are removed. The difference between the defects that were introduced and the defects that were removed will be the defects that escape, plus whatever defects had escaped from the previous cycle. So there can be an accumulation of defects here over time. So, you know, if let's say that there are 20 defects introduced in a requirement specification, we don't do anything to remove them. So the removal number is 0. So now 20 have escaped. And let's say that there's now an additional 20 that are introduced in the coding. So now we have 40 defects that are present, right? Now, excuse me, if unit testing is carried out and 10 of those 40 defects are removed, we now will have 30 escape. Our defect removal effectiveness at that point will be 25% for the unit testing, because there were 40 defects in the system, and 10 of them were removed, and so that is a 25% defect removal effectiveness. So what you can see then is that this flow is happening. Now, the thing is that a lot of organizations, they don't recognize that this flow is happening, but it is. It is happening. Often, you know, as I said, under people's radar, as it were, and then, you know, they're not really paying attention to it. So it really makes sense to get this thought about, you know, what's actually going on with defects into people's consciousness. Now, to address the question that I brought up just a moment ago, and for the professional testers looking at this, they might be thinking, well, how would I measure this? Well, let's say you're in charge of system test, if you're a professional test manager, and you want to know what your defect detection effectiveness is. Well, so in that case, take the number of defects that you detect, okay, system test defects, divide that by the total of the number of defects you detected plus the number of defects that were detected in UAT plus the number of defects that were detected in production after release. Okay, so that's how you would calculate it. Now, sometimes people go, well, you know, how long do I wait? So I mean, obviously I have to wait until it's gone into production and do this calculation, as well as waiting for UAT to be finished. Well, how long do I wait? Well, what you should do is go back and look at what the typical characteristic period is during which, say, 80 or 90% of production defects that are going to be reported have been reported. This has a lot to do with sort of speed of adoption. You know, if you're like, say, Google, and you've got your application is, you know, on the web and it's used by a lot of people every day, then to the extent that you have production defects, it's a pretty good bet that 80 to 90% of those will be reported within hours, you know, certainly days, few days, very few days of a release. Some of our other clients that have longer adoption periods, it can be anywhere from, you know, 6 months to a year. This can be a little more challenging to measure. But, you know, typically what we find with most of our clients is that you've got about a 3-month period that is required for the production software to sort of shake out. We see a lot of situations where there's what's called a warranty period, which would be 30 days or 60 days, and then that would be a good, if you have a warranty period defined, then that would be a good cutoff point, a logical cutoff point for measuring this. Another way to approach this is just a number of our clients do, which is, you know, rather than trying to measure this on a per release basis, they just measure it over a long time period, like say a year, 2 years, or something like that. They use measure this quarterly on a rolling 2-year basis, and that or rolling 1 year basis, and that tends to work as well. There's a little bit of error introduced by sort of the releases that just went into production and releases that were in production, but testing had been finished well more than 2 years ago. But those errors tend to be mutually canceling. Okay, so know your defect detection effectiveness, so you can address this issue of, well, the testing has failed because it didn't find those bugs. No, there's going to be some percentage of bugs that you're not going to find. Now, this, of course, leads to the next logical question is, well, what can I expect? What do we see out there in the industry? Well, I've got some data from doing assessments, and Capers-Jones in some of his books, particularly estimating software costs, and can fill in some of these other blanks. So, what can you expect? Well, some interesting numbers here, and numbers I think a lot of people really aren't aware of. So if you look at the requirements reviews and design reviews and code reviews, theirs are able to get out about 60 to 65% if they're done using good review practices. So these are pretty respectable numbers. Excuse me, and that's a lot of defects to get out. Now, if we look at developer testing, unit testing that's done, what you see here is a real range. If it's done poorly, it's at about 10%, which is better than nothing, but not very good. Average defect detection effectiveness for developers unit testing is 25%, according to Jones's figures, and best practices, if they're really, really good, they can get 50% out. Now, we could go and have a whole parallel conversation about, well, why do they top out? Why does unit testing top out at 50%? I think briefly, and this is just supposition, I'd need to do a lot more research on this, but my guess is that you've got a few major factors at work here. One is that there are certain types of defects that simply cannot be detected during unit testing. They will not show up during that kind of test. I think there's also a psychological element of this. It's difficult to test your own work. You bring to that testing the same assumptions that you brought to creating the code in the first place, and if some of those assumptions are wrong, you're going to see test results that accord with your assumptions, and thus you're going to say, oh, that's passed, but it's actually failed. So I think there's that. I think there's also the management not allocating sufficient time for unit testing, so it's often very rushed. I think in addition, there's a skills component here too, is that very few developers have actually been trained in how to do proper testing, which is a matter of some significant disappointment to me. I was very hopeful when the Agile movement, as it were, started to come about, that not only would this bring an increased attention to unit testing, which it indeed has, but it would also motivate developers to get trained in how to do proper unit testing. That does not appear to have happened. We've been offering a testing for programmers course for close to a decade now, and with very limited success. So I think that's another component of this. But anyway, be that as it may, this appears to be the result. Now, if we compare that against an independent professional testing team, in our assessments we find that 85% seems to be about the average defect detection effectiveness. Good teams are in the 90%. We have seen some teams that are in the 99% range fairly consistently. So, this is best practice. Notice that is not 100%. So it's important that people have a realistic expectation about what a test team's capabilities are. They are not going to be able to find 100% of the bugs. And it's especially true if some of these upstream activities, the reviews and unit testing, are done poorly or not at all. Because what one of the things that will tend to drag down a test team's defect detection effectiveness is, ironically enough, low-quality software. You kind of think of testing and the different types of testing and quality assurance activities as filters, and they tend to be specialized filters, specialized at catching particular kinds of defects. And what will happen effectively is if you put a very low-quality product into independent test team, you're clogging up the filter with stuff that could have and should have been removed in earlier stages. So that's what I mean when I'm talking here at the bottom about an integrated testing and quality strategy. We have to have some sort of plan for how all of these different activities get woven together to achieve the desired level of defect detection and defect removal. Excuse me. Okay, now here's another one of these signs of confusion about trade-offs. You hear people talk about, well, good enough. We need to have we don't need perfect software. We need software that's good enough. Okay, I'm fine with that, and that's true. I mean, there are certain places where I would want the quality to be a whole lot higher than others. So, for example, if somebody's writing a video game that's going to run on my phone or my kid's phone, I honestly don't care whether that works. In fact, given that it's a major time waster for my kids, I don't prefer that it wouldn't work in a lot of ways. But it just doesn't matter, right? In the grand scheme of things, it just doesn't matter if something like that works or not. Now, on an airplane, software that's up in the cockpit, making sure that when the pilot pulls one lever that the right thing happens on the wings or in the engine or what have you. Yeah, I want that to be really, really high quality. I don't want there to be trade-offs made on that. When people can say, well, geez, if you take that kind of standard and it's going to take forever to get software done. Well, no, not necessarily. This is optical illusion isn't quite the right word, because optical illusion would imply that this is a illusion created by some sort of bending of light or something like that. And this is actually a temporal illusion. It's created by a invisibility of the defect flow up until the very last minute. So that graph I was showing you before about the understanding the defect flow, the reason that it's important is that in many organizations, the defects don't become visible until right at the end. And so suddenly people think, oh, wow, we've got all these defects we have to deal with. Where do those come from? And, we've got limits on time and budget, so we're just going to do as much as we can. Well, no, that all happened because of a failure to have an integrated strategy that looked at things, looked at defects earlier and tried to remove them. Now, not only is this undesirable from a point of view of painting yourself into a corner effectively, and ended up organizations releasing lower quality software than they would have otherwise if they had just dealt with the defects up front. There's actually very, very significant cost issues as well. So you're not only we're going to produce lower quality software, it's the schedule risk and the budget risk is maximized by only dealing with defects very late after their introduction. So we did an assessment for a client a little over a year ago, and what we found was, and this is not unusual, we found that they were relying very heavily on bug removal in their final phases of testing. They were calling their QA test, which was basically analogous to the system integration test of the example that I showed you before. And there were a lot of bugs found in UAT as well, which is usually not desirable. So on an annual IT budget of $1 billion, what we found is they had anywhere from $100 million to $250 million in avoidable costs of failure. So that's a 10 to 25% inefficiency. Now you might be clucking your tongue and saying, whoa, wow, that's horrible. And I agree, that is horrible. I don't think that's necessarily exceptional. I think that to this organization's credit, If we had gone in and done the similar assessment in any number of other organizations, we find similar levels of inefficiency associated with dealing with defects. This is not an unusual number. So, if you're thinking, oh, that's horrible that that happened to them, I'm glad that's not happening to me, I would suggest that it probably is happening to you, because, as I said, this is not at all unusual. What was unusual was that this organization took the trouble to go and say, we have a lot of pain related to defect management, and we need to get a handle on that. We need to understand what's really going on. So we did this assessment. As I said, it's $100 to $250 million in avoidable cost of failure. How do we calculate that? Well, what we did is there was a time and motion study that had been done that looked at the cost of removing defects at various phases in the life cycle. And what we found was that a defect that was found and removed in a review only cost $37. This would be a requirements review. But if it got all the way into the QA testing at the end, it would cost 100 times as much, $3,700. So that's a little over $3,600 in avoidable cost of failure. And that there was a lot of that. I mean, just a tremendous amount of that. We looked at, what could be accomplished and what was being accomplished, and that's how we got that 100 million to 250 million. Now you might say, why the big range? Well, the big range was because there were a lot of issues with the defect data. The defect data was, the classification fields weren't being done very well, and so in terms of measuring process capability, it wasn't the most reliable stuff. And this is the first step that we took with them, was get everybody trained in how to file a proper defect report so people could figure out where those costs of avoidable costs of failure were really, and get those scrubbed out. But keep in mind that extra $3,600, that's effort, right? Software engineering, ironically enough, is one of the most human-intensive forms of engineering, if not the most human-effective intensive form of engineering, and so that's effort. So that's extra effort that's having to be expended at the end of the process. Basically, that's $100 million to $250 million worth. So notice that what that means is that the cost and the schedule implications associated with that. Because if we've got a fixed number of people, that extra effort, that means extra time. That means missing the schedule, right? But the budget hit and the schedule hit associated with that $100 million to $250 million, purely avoidable. Didn't have to happen. It was created by these high escape rates that were earlier in the life cycle. That's why I'm saying that this idea that we have to settle for good enough is a temporal illusion created by an absence of awareness of what's going on with the defect flow early in the life cycle, and then suddenly, as the awareness blooms later in the life cycle, when defects are actually being measured, people say, "Oh, well, gee, we're in a bind. We've got nothing, no choice but to make compromises." Well, yes, but keep in mind that when that happens, the organization is not being victimized by that. The organization has victimized itself. Excuse me here. Yep. Okay, so on to this next point. This sort of lack of awareness of bugs, wild versus captive bugs. So you hear people talk about testing is about breaking software, and sometimes there's even testers who are saying this, which I think is kind of promoting a bad myth about ourselves, is not, and one which is not helpful. Because breaking the software sounds like, for one thing, it sounds adversarial, and it feeds into that idea that we're just going to be victims of finding all sorts of bugs at the end, because that's just the natural order of things. Well, sure, before there was proper medicine and understanding of germs and so forth, the natural order of things is that had these extremely high rates of infant mortality and people getting infections and dying during surgery, right? But that was not the natural order of things. That was a situation that was being created by human activity or inactivity. So similarly here, the quality issues that exist in software, this is not the natural order of things at all. This is human activity and human inactivity that's leading to these situations where software is lousy. And it is, really. I mean, we need to be honest with ourselves about this as software professionals, that the quality of software, I mean, we don't tolerate anything in the industrial world other than software with such low levels of quality. If cars, buildings, bridges, any other sort of engineered artifact failed as frequently and as dramatically as software did, it would be utterly unacceptable to us. And I don't think that this tolerance of this is going to last forever by any means, but I think this is where we are now. So, let's be honest about these things. And someone says, "Oh yeah, you testers, you guys are great at breaking software." It's good to be good at things, but that's not one of the things that we're good at, because we don't break the software. The software comes to us with most of the bugs that we'll have. Generally, there are a few additional bugs introduced during testing in the form of regression and bad fixes to bugs and so forth, but that number tends to be pretty low, below 10%, according to Capers-Jones's studies. So why do people think that this is happening? Well, again, this is an illusion, because so many of the bugs are captured and actually logged during testing that it appears that the software was broken by the testing. But the reality is, as I showed you before, this flow has been going on with bugs being introduced throughout the life cycle, and mostly before the testing even started, as I said. So, this is, again, an illusion, a temporal illusion that's created by the fact that we don't actually start measuring this stuff until we get into testing. So, having a defect removal model like that flow that I showed you earlier will help people start to think about this. Now, this is another way of looking at this. The typical defect introduction rates. This is the same. Let me get the spotlight up here again. This is the same model that I showed you before. And remember, we've got, just to keep it not cluttered, you've got introduction, you've got removal, you've got escape. Introduction, removal, escape. That's going on. Well, typically what tends to happen is that most of the defects are going to be introduced in the requirement specification, design specification, coding, and then the number tapers off dramatically towards the end. But typical industry defect removal rates look like this, which is exactly what you wouldn't want, because it maximizes the cost that you're going to pay to deal with defects. Now, there are some kinds of defects you're not going to find until you get into later stages of testing, like system test and system integration test, because they're associated with emergent behaviors. But there are plenty of bugs that are found during system testing and user acceptance testing that could easily have been found and removed earlier. Every one of those is a wasted opportunity, and poses a significant risk to the schedule and the budget for the project. So what we want is something that looks more like this. Defect removal happens very soon after defect introduction. And of course, this is one of the sort of the philosophical things that I think the folks that came up with Agile got right, which is, let's get the bugs out of the software as soon as we possibly can. The sooner we can get the bugs out, the better we are. Now, Agile's not perfect by any means. There's some challenges associated with it, and if you tune into my webinar, I think not next month, but the month after, I'll talk about the Agile testing challenges. But it also does create a number of opportunities, and it is definitely focused on the quick removal of defects, which is good. Okay, and then the final point that I want to make here is the need to integrate testing into quality management overall, which is something I've been sort of hinting and alluding to as I've gone along. Pardon me, let me have a drink of water here. Sometimes when we talk to clients, especially senior people, senior managers, directors, VPs, executives in organizations, I'll hear this. I'll say something like, we don't test everything we should. We know we're missing important areas. We know that, but only after the fact. So we go out and we release, and it turns out that we had not tested particular areas. And we don't even really have a good sense before we release what we have tested and what we haven't tested, and what's known to work and what's known not to work. There's this sort of kaleidoscopic view of the testing results. There's testing happening at different levels. We've got developers testing, and we've got requirements reviews, and we've got all sorts of other stuff going on, system testing by an independent test team, but no single unified view of what the level of quality is, and therefore no real way of saying we're done. Now, this is very hard to do, so I'm not throwing this out here and saying, well, everybody should do this, right? I mean, some of the things that I've been talking about before, they're fairly straightforward, like, measure your defect detection effectiveness and make sure your testers have proper skills. But this is kind of, black belt stuff, as it were, but it's very important. This is, we have true quality management when you can say we have defined coverage goals for all the different testing activities in the life cycle. And those coverage goals are appropriate to what level of testing we're at. So if you're unit testing, you'd expect to have coverage defined in terms of things like statements and branches. If you're in system testing, you'd expect to have coverage in terms of things like requirements and risks. If you're in user acceptance testing, then it's going to be requirements or use cases, right? But we have a well-integrated view of what should be tested, where we can then have a consolidated view of what the status of the testing is. In other words, test results based on what was to be tested and what we actually found, giving us a single view as are we ready or not. So to give you an idea of that, this is from a testing policy from one of our clients, and what they have here is, let me get the spotlight up again. We've got clearly defined levels of testing, okay, and we've got owners. Notice that CIT, component integration test, is owned in part by development and in part by QA, but they have different objectives in their ownership there. And we have clearly defined objectives of what should be accomplished, and then below this, for each one of these objectives, they have metrics about what level of coverage and what level of defect detection effectiveness do they want. So we have a holistic view of what's to be carried out here. So conclusion here is that we've seen 5 areas where confusion about test management and quality management does arise, and the problems that it can create. There's not just problems, there's also opportunities, because if you take these lessons to heart, institute some process improvements in your organization, then you can go a long way towards having higher quality releases. So just to recap, make sure that the people doing the testing have the right skills, that you've got the right mix of skills across all the different groups. Understand the defect flow that's actually going on in your organization. Have a quantifiable defect detection effectiveness for the different testing activities and quality assurance activities that go on. Measure the cost of removing defects at different stages in the life cycle, and you'll almost certainly see that those costs escalate dramatically as you get later, and that will help make everybody aware that these trade-offs, these temporal illusions of the need to accept lower quality software because we don't have time and money to do it right, is just that. It's a temporal illusion that can be avoided. Again, understand the defect flows, understand your defect removal models, and where the bugs are coming from and where they're getting caught, and how to better manage that. And then work to integrate testing into an overall quality management strategy, rather than saying, well, we do testing and that's how we manage quality. By doing these things, these 5 key lessons and applying them to your overall software engineering process, we can indeed dramatically improve the quality of the software that is being delivered, and make sure that the testing that's being done is very effective and efficient. And I think there are certainly many things that we still have to learn about software testing and software engineering. It's an exciting time to be in this field because there's so many things left to learn, left to discover. We get to sort of build the foundations of an engineering profession here over the next 50 to 100 years. A few hundred years from now, I mean, software engineering will be like most other forms of engineering. It'll be fairly well understood and mathematical, but now we're really in a very interesting and exciting time to be in the field. So there's a lot left to learn, but I think there's also a lot that has been learned already, and I think if we simply did a better job of applying the things we already know to building and testing software, we could produce much better software. I hope we will. Okay, so as is usually the case, I'm going to go ahead and put the advertisement up here and go into question and answer mode. Give me a moment while I undock the question tab here. Well, Susan says, I need to leave the meeting about 35 minutes early due to another scheduled meeting. My apologies. Thank you. No problem, Susan. Yeah, I see you probably already have checked out, or maybe not. Maybe you're about to. These are recorded, and so you can always go back and catch the part that you missed in the recording. For those of you who are thinking about the PDU aspect of it, provided that you listen to the entire presentation itself, you can claim the PDUs. If you miss some or even all of the Q&A session, that's not an issue. But you have to listen to the entire presentation in order to qualify. Now, question came up here. What is the PDU code? So let me go through that again quickly. The PDU code is TMQM, Test Management Quality Management, 100. TMQM 100, and our provider ID, RBCS's provider ID, is 2986. You should be receiving an attendee email shortly after, like in the next 24 hours or so, and that code, I believe, will be in there as well. So Ken's got a comment here following on to my comment about there being a finite amount of time for testing. Ken says, there is also a finite amount of imagination for inventing tests. Users do the damnedest things. Our first reaction to production bugs is often, they did what? So that is, yeah, that's definitely can be true, Ken. I mean, I think there's an interesting difference here between IT software and enterprise software and sort of end user mass market software and internet applications. Or I've laid those out in sort of a spectrum from most able to understand what the users are going to do to least able to understand what the users are going to do. I mean, if you're building software for IT applications, something that's going to be used in-house, or by some other sort of captive audience, like avionics software in the cockpit of an airplane. It is possible to clearly identify the user base and their level of experience and what their expectations are and the exact problem they're trying to solve. And, in that case, our testing can be very much targeted at this is what the users are going to do. But if you go off over into the other end of the spectrum, applications running on the internet that anybody can use and get to, you basically have no control over what the skills are and what the experience is. I mean, think in an internet banking application, you might say, well, it's a fairly well-defined situation and what it can do and so forth. Well, yeah, the capabilities can be well defined, but to Ken's point, you're going to get those "they did what" situations where somebody figures out how to do something that's just really bizarre and doesn't make any sense. So that's definitely true, and I think to the degree that it's hard to predict what your users are going to do, that's going to tend to pull down your defect detection effectiveness for your professional testers, and probably increase the need to have more amateur testing done by actual intended users. And there are various ways of making sure that you get the right mix in there, right mix of people, so that that is representative of the final user base. So Lashani asks, is it advisable to have the same team to handle both testing and quality assurance? Well, I have. So to go back, you're perhaps keying off of that example I was giving earlier about the testing group that had they were in charge of the reviews, the design reviews, and the requirements reviews, as well as being in charge of the system integration testing at the end. That actually worked very well in that organization. Now, if you're talking about quality assurance, like who's in charge of overall quality management, should that be in the testing group? Well, kind of depends, right? A lot of times when people talk about quality assurance, they're talking about process assurance, in a sense of like making sure that other groups are following best practices. That's that process cop stuff. I talked about this in my webinar last month. If you missed that, you can go listen to the recorded version of it. But it's, that's the process cop stuff is not usually a good fit within the organization. So I'd refer you, Lashani, if you didn't catch last month's webinar, to go take a listen to that, and you'll get from that, you'll get my thoughts on, do we want process enforcement in a testing group? So Anne asks, have you published the professional testing efficiency data in any kind of a formal study? No, not. I've referred to it occasionally, obliquely, if you will, various articles and books that I've written, but no, I've not gotten around to doing a full-blown study of this. I mean, it'd be interesting to organize, but at this point, what I have is data from assessments done for clients around the world. It would be fascinating to carry this out across, say 1,000 organizations and carefully chosen study groups and so forth. The problem is that I'm not sure how I would get any organization to pay for it. And while this would be great information to have, the bottom line is that if we can't get paid to do something of that magnitude, we can't afford to do it. If anybody can think of a way of monetizing some kind of study like that, getting people to come up with the money to pay for it, I'd be happy to organize it if I could figure out how to make money off it. It wouldn't have to be a lot of money, but it'd have to be enough that justify us doing it. Part of the issue would be you got to make sure that it's apples to apples, right? I know how to measure defect detection effectiveness. I've been doing it for a number of years with a lot of clients. There does tend to be a learning curve for each of our clients as I teach them how to measure it properly. It's there's some complexities. So if I just sent off a questionnaire to 1,000 different organizations saying, please tell me your defect detection effectiveness for the last 24 months, they wouldn't even know how to answer that question. And a lot of them, some of them would, but a lot of them would not. And I think some of the answers that I would get, the measurements wouldn't actually be valid. I mean, we ran into this with a client during an assessment earlier this year where they came back with some numbers, and I looked at the numbers, and they thought the numbers were correct, but then I dug into them a little further. I'm like, well, no, actually, you're including defects found in other levels of testing that shouldn't be counted, and when we recalculated it, it was a much lower number. I see Luke had a similar question. Is this a case study that RBCS did? Can we get a copy of that study? Oh, well, I'm not sure, Luke, which case study you're referring to. All of the case studies that I cited are from actual projects that we worked on with clients throughout this presentation. Now, most of those, to the extent that they're written up, they would be written up as an assessment report or something like that, which would be client confidential, so I would not be able to provide it. We can talk in generalities about things that we've learned with working with our clients, but my associates and I can't really distribute client reports and so forth. Karen asks, will we be able to obtain these slides? Yes, for those of you who missed the opening few minutes, or opening couple minutes, I've been trying to make the intro shorter. The opening minute or two, I mentioned that you can find a PDF version of the slides. Go to rbcs-us.com, and in the upper middle, you'll see the Resources tab. Go to the Resources tab and navigate from there to the Basic Library, and you'll find the slides there in PDF format. Let's see. Douglas asks, can you suggest any test management tool that could help? Well, there are a number of test management tools out there. I'm not going to make any specific recommendations about any specific tool because you need to go through a careful process of assessing tools before you select them, and there are a number out there, some free, some commercial. I think the proper process to go through here, Douglas, is to identify your requirements, just like you would in any project, and then identify the tools that might meet those requirements, kind of come up with a short list, if you will, and then go through an evaluation process, and ideally evaluate in a live setting with your actual test data and so forth. That, remember, the vendor's canned demo will work. You're not going to learn anything interesting about how the product is going to work in your context from the vendor's canned demo. But definitely having proper test management tools, especially defect management tools, in place, I think is extremely important in terms of managing testing and managing quality. So Carlos says, Rex, do you know any technique to test the skills of the QA analyst? Great webinar. Thanks a lot. Well, I mean, obviously, one of the ways of evaluating and sort of graduating skills for QA staff is the ISTQB certification program, which has different levels of skills, and once you get to the advanced level, there's different types of skills. It kind of depends, Carlos. I mean, what you're trying to do, right? I mean, so this came up with a client earlier this year. We were talking about interviewing testers, and if that's what you're trying to do, you're trying to come up with ways of interviewing them to select them. Excuse me. There's there's a number of things you can look at. I mean, there are qualification questions, if you will, where you ask questions that have clearly defined yes/no types of answers, or true and false types of answers. Like, if I give somebody a specification of a particular screen and I ask them, okay, identify the boundary values and the equivalence partitions for all of the fields that are shown on this screen, then that's a qualification question. There is one right answer for that and a number of wrong answers. Now, there's actually more than one right answer in the sense that that's sometimes you can do sub-partitioning, but you get the drift. There's proper application of the technique, and then there's improper application of the technique, or totally not knowing the technique. So that's one of the things that I would say is, look at these kind of qualification questions. But you also want to, look at other sorts of aptitude types of things, which are a little harder to measure. People's attitudes, their level of patience, their ability to function in a less than perfectly defined situation. There are a number of things that I think make someone a good tester. And I believe I did a webinar on this a year or two ago. If not, I'll make sure to add it to the schedule about what makes a good tester. So Ruth asks, what strategies have proven successful in implementing quality management where development standards and processes do not exist? Well, Ruth, I mean, the most effective way of motivating change, and this is true of both individuals and organizations, some of you have heard me say this before if you've listened to other webinars, the most effective way of motivating change is pain. That's for human beings and organizations, that's the thing that most reliably gets them to change the way that they behave. So, some near-death experience where there's a horrible release and the customers or users are just completely up in arms, and there's talk of the company going under or the organization going under or being disbanded, and that kind of thing tends to really grab people's attention. There's the old cliche about there's nothing like the prospect of a hanging to focus your mind. And unfortunately, that's really what it takes. In a lot of cases, it takes a situation that is very painful. Usually, the pain is associated with potential loss of money, loss of job, and so forth. That tends to get people's attention. Now, the thing is that sometimes the pain is there, but it's just that people aren't aware of it as pain. They think of it as the natural order of things. So in this case, Ruth, what you can do is kind of create pain. Not so much create pain, but create an awareness of the pain. Like that organization that I mentioned before that had the $100 million to $250 million in avoidable cost of failure. They were, not happy with their defect management situation. They knew that was not going well, but they had no idea the order of magnitude of the loss that was being felt. And once we went in and did that study and came up with those figures, that really focused their mind. So since that's not by any means an unusual situation, I think that's actually probably a tool that is available to a lot of those of you who are listening right now, that you could go off either on your own or with the help of our organization and measure the avoidable costs of failure, and really motivate some change. And is being able to recapture 10 to 25% of the IT budget, that's a big deal. Andrew asks, are there any standard methods or principles that can be used for calculating the defect removal cost during the different phases of the SDLC? Well, it was pretty much that graphic that I showed you earlier, that showing the defect flows. What you have to do is have an ability to measure the defects that are introduced, the defects that are detected, and the defects that are removed in each phase of the life cycle. Now, a lot of times people object when I say that. They say, oh, that's too heavyweight. We can't have everybody filing Bugzilla bug reports or Quality Center bug reports on defects that are found in unit testing, for example, or in reviews. Well, you don't actually have to go to that level of formality necessarily. Some of the results from earlier quality assurance and testing activities be captured with spreadsheets. It's not so much where the data goes. I mean, obviously, a programmer does not need to document the steps to reproduce a failure. If they're looking at a bug in unit testing and they just reproduced it with an automated test, and making them go to that level of effort is not helpful. But it would be good to know how many defects and of what type were found and removed in each phase of the life cycle. So that's really what I'm talking about here. You want to try to capture that information. Richard says, "Hi Rex, thank you for all your help and support. Where in the library would I find this specific webinar? I would like the rest of my team to view this one." Okay, so Richard, in about, well, usually it's 2 or 3 days, but with the holiday here right in the middle of the week, this could get a little funky. But certainly within a week, if you go to the rbcs-us.com website, go to the resources page, and navigate to the digital library. Now, it's the digital library. What you'll find is the recorded version of this webinar will be posted there, like I say, usually within about a week. And then people can view and listen to this webinar. The slides themselves are currently posted in PDF format, and they're on the basic library. The thing is, the slides, and the slides are what they are. They're bullet points and graphics, and they're not necessarily self-explanatory. So, I'd recommend, sending people to the digital library. Now, if for whatever reason there's some problems with getting people there, we do create an audio podcast of this, which can be, it's posted in the iTunes store, and can be downloaded from there. And someone could listen to that and go through the PDF slides. But really the best way is just to go to the digital library and listen and follow along in the presentation. So let's see, Ken's got a follow-up here. Ken being the fellow who made the comment about the user did what? Says, that's what I have, social software, including editable web pages and microblogging, aimed particularly at non-technical users and not enough UAT. Yeah, so, I would say that'd be something worth looking at is, can you identify different cadres, if you will, of users. And I say cadres here, I mean, I'm talking about some way of organizing users, breaking them down into groups that have, similar needs, similar levels of experience, etc., and see if you can come up with some sort of beta program that allows you to, get those people involved in a beta test and get their feedback early. There's also, in some cases, and I'm not sure if your software can do this or not, some organizations do this, they have the ability to do what are sometimes referred to as split runs, which is the way to visualize it is, imagine if you came to our website, rbcs-us.com, and instead of everybody seeing the same thing, we somehow partitioned the incoming users so that, say, 90% see the current production version of our website, but 10% see a new version. And we solicit feedback from the ones that get directed to the new version. And then if there are problems, we can very quickly redirect everybody back to the old existing version while we fix those problems. That can be a way of implementing a sort of a phased rollout with web-based software, which you might consider. Shesha has a comment here. Management assumes people who have worked in banks in real time are better testers than people with technical skills, even though bank employees do not have technical skills. And then it says suggest. Maybe you're asking for suggestions. Well, yeah. I mean, again, this is just the this is that fallacy that I was talking about before, that sign of confusion of, anyone can test, or in this case, it's kind of a special manifestation of it. Any user can test. That's all we need are users. The thing is that users will not necessarily have a good understanding of the technology, so they won't know the weak spots. They won't know where to poke and prod the hardest. They don't have a good understanding of what's referred to as technical risk, where the product is likely to fail. And they also don't have testing skills, so users will tend to both over-test and under-test. They'll do too much testing of some things, which is what we saw in that case study before of the 25% of the test being redundant. They do too little testing of other things. So, organizations think they're saving money by doing this approach, but they're really not. Let's see. So Diego says, can you describe in a few bullet points what you would include as quality management metrics for this presentation? I don't think I'm going to be able to answer that question in just off the top of my head. What I would do is I'd refer you to, you can either go back and listen to a recorded version of the webinar on testing metrics that I did 6 months ago or so, I think. Or alternatively, you can pick up a copy of our ebook on that, testing metrics ebook. And that might give you some thoughts on putting a metrics program in place. But I don't want to try to just give a 30-second answer to a subtle question like this. The recorded testing metrics webinar is available for free in our digital library. The testing metrics ebook is on our website, and if you go to the store page, you'll find it there. It's $10 or something like that. So Priya has a comment here, testing the functionality versus that scenario will never happen in the business world. The system lets me do something that's not supposed to. It should be treated as a defect and should be fixed. Does not matter if the defect would ever occur, keeping the business logic in mind. What are your thoughts? Well, I understand that perspective, Priya, but I think that the trouble is that if we, as I said in the presentation, these trade-offs between schedule, budget, and quality all materialize at the end of the project. Now, if you're at that point, you're at the end of the project, and you are in that crunch, you've got to, at that point, you have to play the hand you're dealt. Okay, it's a crappy hand, and part of the point of my presentation was this is not the natural order of things. Organizations do this to themselves. It's a self-inflicted wound when you get into that situation. Nonetheless, when you are in that situation, you have to choose to respond to it effectively, which means that you have to be able to do effective bug triage. And so while I might want to see every defect that is detected removed in testing, I recognize that in many cases they will not be. So, it's I think something we just have to accept that a bug that is something that's going to immediately impact users' experience of quality is different than a bug that is unlikely to ever impact any user's experience of quality, and thus the prioritization has to be different. So that would be my thought. But again, I think it's important to capture that, and people need to understand those are self-inflicted wounds. The fact that you have to do bug triage is a manifestation of the just general immaturity of the software engineering process across many organizations, most organizations. Rakesh says, you touched on Agile testing during the discussion. Any thoughts or recommendations on tools for Agile environments? So again, Rakesh, I don't get into making recommendations for tools. We will work with clients to help them select tools that are appropriate to their specific needs, but I'm not in the habit, nor do I intend to get in the habit of rattling off the names of tools, because there's too much contextual stuff that goes into selecting the right tool. That if I just say, oh yeah, we've got clients using X, Y, and Z, and they're all real happy with it, you might go out and pick one of those tools and be extremely unhappy with it. Now, as far as Agile, as I said, I've got a presentation, basically a review presentation. Excuse me, I've got a wasp in here. A review presentation of the Agile testing challenges. It's going to come up. We're going to do that in a couple months. We also had the Agile testing opportunities, which I did. I a few months ago, and that's available as a recorded webinar. It might be repeated some subsequent point. Excuse me. Elias asks, how can the performance of software or web applications be efficiently tested? Well, if by efficiently you mean cheap, that can be a challenge. I mean, that's, performance testing in general is an expensive thing. And so, to get us back to this general topic and talking about quality management, that's something else that's really worth keeping in mind here, is that quality has both functional and non-functional elements. It certainly is a common industry worst practice to test the functionality and forget that there are important non-functional elements like usability and performance and security and so forth that need to be tested. Or people are aware, but then they don't do it because it's too expensive, or it'll take too long, and what have you. So that is unfortunate. But make sure that when you think about testing and you think about quality, that you are looking at both those functional and non-functional elements. Let's see. So Infius says, say for example, UAT successfully passed. However, we have bugs experienced in production. Who should take responsibility on these cases? Either the service provider, users, or customers, or both? Well, to go back to a point that I was making, and maybe I should have been a little bit more explicit about this, and I was talking about the process's quality capability. Part of the point of knowing what your defect removal or defect detection effectiveness is from a test team point of view is to move away from this idea of who is to blame for the defect in production, and just understand that there are going to be some number of defects that will be identified in production. It's just that's the case. You're not going to have 100% defect detection effectiveness, and even if you did, you probably wouldn't fix every defect that was found, back to the point I was just talking about. So, there are going to be some defects in production. So really, this is a matter of what the process's capabilities are, not who's to blame, not whose fault it is. So I think we need to get away from this idea of it's somebody's responsibility that this happened. Now, should we learn from defects found in production and improve our process so that we don't miss those in the future? Yeah, absolutely. Having that kind of feedback loop is very important. So, who takes responsibility to act? Well, certainly the test team should take responsibility to act on defects that are found in production, in the sense of asking, how could we have found that? Is there a way we can change our process so that we don't miss bugs like that again? And you need to think of bugs like that, not that specific bug, right? You don't generalize it. Okay, Raquel asks, the defect detection in production is indeed sometimes a result of the unexpected ways the user interacts with software, but a lot of the time is due to a gap we left in testing for reasons like time constraints, skills gap, etc. Is there any metric you'd recommend, particularly in addition to the defect detection effectiveness, to raise awareness of the cost it represents, the cost represented by the gap left several test levels or even iterations before? By the way, great webinar, thanks. Well, thank you, Raquel, for the kind words. Well, I mean, defect detection effectiveness, is certainly one of the things I think we want to measure for each level of testing and each activity, so that we get a sense of, what our capabilities are catching bugs versus missing them. But I also think you want to look at a technique called cost of quality to try to understand what your avoidable costs of failure are. That's what I referred to earlier. And Luke, this might get to what you were interested in, that the case study with, how do we quantify the $100 million to $250 million in losses? There's a technique called cost of quality. Now, I did a webinar on cost of quality at some point, I believe, and you can find a recorded version of that in the digital library. Also, it's either on the basic library page or on the articles page. There's a article on testing return on investment, and that would be something that you could look at that would help you understand the concept of cost of quality. I've also talked about cost of quality in a number of my books. It's described in detail in Managing the Testing Process, the third edition that came out a couple years ago. So, the number of things to look at there. But I would definitely recommend looking at cost of quality additionally, Raquel, as a metric to try to help people understand, this is the amount of waste, lost financial opportunity that's associated with our current process capability. Because sometimes people will just say, oh, well, okay, we don't find all the defects. Well, say like error, it's defects get out to customers. If you could say, no, really, we don't find all the defects. We don't find, enough of the defects, and this is costing us 10 to 25% of our IT budget. That's going to get people's attention. As you better believe that when I put the results of our assessment out in front of the executives at that company, that 100 million to 250 million loss, that I had their undivided attention. There's nothing like figures like that to really focus people's brains. So Wanda says, thanks, great information. Thank you, Wanda. Glad you liked it. We have reached the end of our schedule, so I'm going to conclude with some final thoughts on resources. Remember to sign up for these free monthly webinars. You will be by attending on our list, so you will get invites to sign up. But if you ever miss one, go to rbcs-us.com and you can sign up. If you're interested in this webinar or any other webinar being presented for your company, send us an email at info@rbcs-us.com or contact us via our website. Sign up for our free newsletter. This is the bottom right side, I believe, of the home page, rbcs-us.com. This will get you valuable discounts on consulting and training services and a regular newsletter from us about what we're up to. You can follow us on Twitter. We're RBCS on Twitter, and on Facebook, we're RBCS-INC. Do remember to check your email over the next few days, see if you are the lucky winner of the e-learning course. Check out my blog, rbcs-us.com/blog. Feel free to post comments, or if you don't see something that already out there, there's a lot of content already out there, but if there's something else you'd want to discuss with me, send an email, info@rbcs-us.com. I'm a little backed up on blog posts lately, but with any luck, I'll have a chance to catch up a bit on this summer. Check out the digital library. As I mentioned before, we've got recordings of the webinars. We've got podcasts and videos. Find the podcasts on iTunes, and you can also subscribe to the RBCS channel on YouTube. We offer these free resources as a service to the software testing community.